welcome to this session. In this session we are going to discuss about XPATH operators and expressions and data types available. See, already we have discussed what is XPATH. By using XPATH we are able to traverse through node tree and we can locate any nodes available in the XML file. Based on XML file, the node tree is constructed. By using the node tree, we can traverse through the node tree. We can get any information from the XML document through XPATH. There are two important operators are available in the XPATH: slash and dot. The slash operator separates the previous level to the current context, as well as dot refers anything that we will see later. And second point is XPath defines several operators that can be used in the XPath expression, right? Several operators, as you know, in any language we can have set of operators: arithmetic operators, boolean operators, logical operators. Like set of operators are available. Those operators can be used in the respective expression. Arithmetic operators used in the arithmetic expression, relational expressions available, then that expression contains relational operators, and so on. Why we are constructing this kind of expression? In order to locate the nodes. So by using XPath we are able to locate the nodes available in the node tree by means of expression. That expression comprises set of operators. There are three broad categories summarized here: standard operators, arithmetic operators, and access. First we will see the standard operator. First set, slash, dot, double dot, at. These operators grouped together called as expression operator. Slash means it is a path operator used to indicate successive levels of the node tree hierarchy. As I said previously, one level is separated from other levels because in the node tree all nodes are arranged in hierarchical model. All nodes are arranged in hierarchical model. Root node, and then next level node, and so on, based on the document structure, XML document structure. The node tree is constructed, and then in order to traverse through root node to last node, we need that separator. We need the separator, so that the path indicator it refers or it separate the other levels from the current context. And then dot refers to current context node. It means you are currently where you are living in, or currently, because we are traversed through the node tree. At one point of time we may be in the first level node, then that first level node is called as current context node. Root node and other levels are separated from the current context. So in order to refer any information in the current context, that will be referred by dot. And double dot, parent, right? Parent of current context node. You are in the third level, you are using double dot. It means you are referring second level content. You are referring second level content, that will be represented using double dot. At symbol is used to indicate the attribute reference. See, we know that in any element, in any XML element, we can include set of attributes. For example, when you are saying body tag, it has background color, background texture, and so on. Those background color, background texture called as properties or attributes. Likewise, in your tag, in your XML document, in order to refine your, or in order to provide more information about a particular element, we can include the attributes. We can include the attributes. So all such attribute can be referred by using @ symbol. And another set of operators grouped together is called as wildcard operators, right? Wildcard operators. Star, @, node, /. Star refers select or match any element node in the current context. Already we have discussed select equal to, that is the property available in the apply template. Apply template tag select is a select and match available in template and apply template tag. In those cases, if you want to select any element node in the current context, then that will be referred, element node will be referred in the current context by means of star. @, it means star refers select any element in the current context. After that we are saying @ symbol, so that it select any attribute node in the current context that will refer. And then node, it is a function. It is a function. It select all nodes in the current context. It select all nodes in the current context of any type, right? Current context of any type. And then // you can skip levels in the hierarchy. Generally, when we are traversing, we need to travel from root node to leaf node. Suppose you want to skip a level. You are currently in the first level. You don't want to use the second level. Directly you wanted to refer the third level. Then you can make use of /. It allows you to skip levels in the hierarchy. And then the other operators, square bracket and or symbol. Square bracket called as predicate operator. Predicate operator that will be used to filter a group of nodes. That will be used to filter a group of nodes. And then either or match. The next symbol is called as optional operator. Optional or choice operator we can say. In XML it is called as choice operator. We can select A or B or C. We can select either A, either B or C. We can select any one particular portion from the expression by means of choice operator. Choice operator. These operators comes under standard operators. These operators comes under standard operators. And next one, arithmetic operators. Arithmetic operators, as usual, plus, minus, star. Plus, minus, star. Here slash is not given. Instead of that, div, division. Div will be the division operators according to XPATH notations. And then the equivalent example is also given. 6 plus 4, 6 minus 4, 6 into 4, right? So you can apply those operators between two operands. 8 div 4. And then equal, not equal, less than or equal to, greater than or equal to. If you want to equate two operands, then that will be done by using equal, price equal to 9.8. See, these conditions can be given, these kind of arithmetic expressions which includes arithmetic operators, right? You can use these kind of arithmetic expression in the predicates, in the predicate operator, and then not equal, price not equal to 10 or 9.8, and less than or equal to, greater than or equal to. These things already we have discussed. And then greater than or equal to, or. The or operator combines two conditions. Any one condition true, then the entire expression becomes true. And operator. By using AND operator also, we are able to combine two expressions. And those two expressions, any one gets false, the entire expression becomes false. And then modulus operator, MOD, 5 mod 2. We will be getting remainder of this division, 5 divided by 2, remainder of this division, we are able to get it. get it. So up to this, XPATH arithmetic operator is over, and then XPATH accesses. XPATH accesses. XPATH accesses are several operators which is not in the form of operator, some sentence like model available. By using that sentence like model, we are able to traverse through the XPATH node. As I said previously, XPATH accesses sentence like model or keywords available. By using those keywords is called as access name. By using access name, we are able to refer exactly the specific element, ancestor or self, and so on. The access name is available in the first column. What is the equivalent meaning is present in the next column, second column. If you are giving ancestor in your XPATH expression, then it will select all ancestors, parent, grandparent, and the next level towards the top of the hierarchy from the current node. And next one, ancestor or self. It select ancestors as well as the current node, current context, as well as the current context. Attribute, it select all attributes of the current node. In the current context, it select all attributes. And next one, child. Children of current context, right? Current node. Children of current node will be selected when we are specifying child. Descendant and descendant or self. It means previously ancestor. All ancestor nodes are selected. All ancestor nodes are selected. Now all descendant nodes up to leaf level. All descendant nodes up to leaf level will be selected. In the descendant, it won't take the current node. Descendant or self takes or assumes current context also. And then following, it select all elements in the document. All elements in the document followed by the current node. I mean closing tag of the current node. Following sibling. It select sibling as well as all followers. It will select the siblings and all followers. And then namespace. We know that namespace is a technique in which we can group the nodes based on some scenario, based on some context. So when we are specifying namespace, it will select all namespaces of current node. And then parent, it select parent of current node, current context. And then preceding, right? Preceding, here it select all the nodes that appear before the current node in the document. Before the current node in the document. This is opposite of following. Following, what happens there? After closing the tag of current node, all other followers will be selected. Here preceded nodes are selected, including sibling selected in the next case, preceding sibling. Select all siblings before the current node. And then self, it refers current node, so that it will select a current node. These are all the XPATH accesses available here. Right? After this, we will see some example regarding this operators, XPATH operators. First, we will see the arithmetic operators. First, you need to include XML version and encoding scheme UTF-8. And then we are writing XSLT, so that XSLT version XSL : style sheet version equal to 1.0 and XML : XSL namespace is XSL. And then that will be referred this particular site. This particular URL will be referred whenever we are using XSL tag. See, this is XSL tag. In order to refer this XSL tag, whether you are writing the XSL tag is correctly or not, in order to refer this, it uses the URL. So first template, all elements from the root match equal to /root element. And then HTML body, chef is written in H2, and then in the table the result is stored serial number, ID, first name, last name, income status, and then XSL : for each, that we'll see in the, actually we are going to see this in the next week. But here, in order to explain the operators, I required this syntax. XSL colon for each is used to select each and every element available in the XML document. What is the criteria for the selection? Class/chef. Wherever you are finding class/chef label, it select all elements from there, and then select equal to position and at ID, attribute ID, first name, last name and income, everything gets selected, and that will be printed in the tabular column, right? Tabular column that will be printed. And then another choose condition. This is similar like switch case in other languages. Switch case in other languages. Choose, what is the test condition? The XSL colon when income divided by 35,000 greater than 1. You will be getting income, you are dividing the income by 35,000, you will be getting greater than 1. Similarly, that will be displayed in the senior level, and team lead level 40,000. Team lead level 40,000, greater than 40,000 will be the income, in such a way that will select. Otherwise the assistant will be selected, and then close everything. Okay, and this is arithmetic operator example. You are able to execute this. I'll show the output of this later. And then Boolean operator, as usual, open the XML version equal to 1.0 and style sheet version, and XML namespace colon XSL http colon / www.w3.org based on the version 2001 or 99. Two different locations are there. XSL/transform, and then XSL colon template match equal to slash. In all elements available in the XML document, from the root element the template will be applied. Apply templates, and then match equal to list. Wherever you are finding list, it will select that, and then serial number, item, carbohydrate, fiber, fat content and kilograms. That things will be printed in the table, and then we are selecting. This is very, very important. Here we are using the Boolean operator or item type equal to veggie whisk or type equal to grains model. If that item is equal to, item type is equal to this category and this category, then that will be selected, and that is printed in the tabular column based on the expression. See here, we are giving the expression, Boolean expression here. Based on this Boolean expression, the items will be selected and displayed in the table. And in the next example, comparison operator. See here, income greater than or equal to 40,000. Comparison operator. Greater than or equal to, less than or equal to, not equal to, like operators can be used in this expression. And we will be checking here greater than or equal to 40,000. Then the element that matches or that satisfy this condition, those elements only be available in the result. Only be available in the result. We'll see the first output, arithmetic. See here, chef, serial number, ID, first name, last name, income, status. Senior level, assistant, senior level, those records will be displayed. And the second one, Boolean operator, carbohydrate, fiber, fat content, kilogram, 720,500, those records fetched and displayed in the HTML form. From the XML document, the records are selected. And then another XPATH operator, chef, serial number, income, status. So no condition satisfies this particular status, so that nothing is displayed there, and then 40,000, 50,000 will be the result. Okay. So up to this, we will end up the today's session. Next topic we will see in the next session. Thanks for listening. Thank you.